Car A is 10 miles due west of car B. Car A is moving north at 20 miles per hour. Car B is moving west at 5 miles per hour. At what time will the distance between the two cars be the least? What is that minimum distance? So it's the least distance that the time it takes to get to the least distance. So we need an equation for the least distance first, the minimum distance. So step one down here is we're trying to minimize the distance between the two. So car A is heading north at 20 miles an hour. Car B is heading west at 5 miles an hour. So we want to minimize, when will this red distance, this D distance here, be the least? Okay, so the distance that car A has traveled, or at any given time, is using distance equals rate times time. So 20 miles an hour times the unknown amount of time that has elapsed. Distance B, this blue distance here, is its speed times its time. So this distance, 5 times t, this distance is 20 times t. So we create this right triangle. So this green distance here, since the total distance starting A to B is 10, and this distance is 5t, so this green distance is 10 minus 5t. So we have this right triangle. So we want to minimize this hypotenuse. So is leg squared plus leg squared equals hypotenuse squared, and I just took the square root of both sides to get d. So we have this expression using the Pythagorean theorem, and so we write it as a exponential function. Now steps 2, 3, and 4, we can skip those because the distance function is already in terms of just only one variable. So there's no need to do steps 2, 3, and 4 because the purpose for those is to get this function here all in terms of one variable. So we can go straight to step 5, take the derivative, which is the chain rule. So bring the power to the front, subtract, take the derivative. Now I went ahead and wrote 20t squared, square the 20, square the t. I left this the same. There's no real need to multiply that out. So I take the derivative of the inside quantity. So 400t squared derivative. Derivative of this part is the chain rule again. So bring that 2 to the front, subtract, then we take the derivative of the inside in -5. So if we simplify this bracket, so distribute the 2, distribute the -5, this is what we have. Now we set that equal to 0. We set this whole expression equal to 0. We don't have to be concerned with this first part here. We don't have to be concerned with all of that because that is in the numerator. And a fraction is equal to 0 only when the top, this is the top, is equal to 0. So we set the top equal to 0, solve for t, and we get 0.118 hours. So at that time, 0.118 hours after they start moving is when the distance will be the least or the minimum. So we take this time, plug it into our distance equation, and we come up with 9.7 miles. So that's the least amount of distance that is between these two cars.